Now members, let us see how we find a reciprocal, a general formula, reciprocal of a number using the Newton's method. So the question is, show that the derivative formula based on Newton's method for finding the reciprocal of a number b is given by this. Here you have to be careful with the signs of powers. So what we know that the derivative formula, the Newton's formula for finding roots of numbers, roots of equations, is given by this, where the equations have the form that. So we need a function like this. So they are giving us a number. So we say there, let the reciprocal, that is what we call the reciprocal of a number, be x. So when I take this up, I have b power negative 1 equal to x. Now I want this number to be with power 1. What do? I multiply with the same power equal to x, power negative 1, both sides. So from here, so I have b equal to x now power negative 1. Take this side, I have x power negative 1 minus b equal to 0. Or even if you take this side, no problem, everything will be the same. So, or someone can say, you can take this side, b minus x power negative 1 equal to 0. This or this, any, as long as this is going to be an equation. So, let us take this one. So, let's say, let my f of x be b power negative x power negative 1. I'm taking this because I'm seeing when I'm differentiating, I'm not going to be disturbed with the negative. So start this one now, we need its derivative. When you say this, we get 0, and you say this, we get x power negative. We lower this power, which will give us a positive there. Now from there, what happens is we need to evaluate them at, when I evaluate this at xn, I'll be having xn power negative 2. When I evaluate the other function, my function at xn is going to be b negative 1. After that, now I substitute into the formula. It's going to be now xn, then minus this, then the whole over the derivative, which is xn minus 2. So what we do, we cross multiply this thing here. When I cross multiply this here, I'll be having xn plus 1 equal to 2 times xn power negative 2 minus b, then plus xn minus 1. The whole thing, I'm dividing it with xn minus 2. Some people forget that after getting the LCM. So when you simplify this, we get something like numbers of the same base, we add the powers, we shall have x power negative 1n plus this, then minus b, the whole over minus 2. And this will see these are the same, so we have 2x negative 1n minus b, the whole over n. So you see, this is, I can write this as 2 over xn minus b divided by 1 over x squared n. If I take this one down, then simplifying there, and you get the reciprocal 2 minus the LCM over xn, the reciprocal here will be x squared n. And this one goes with that. And so our xn plus 1 will be now, we look at our formula, we have xn into 2 minus b xn, and that will be our formula there. So after getting that, we're asking hence find this. So if you compare 1 over b with 1 over 13, you see that our b is going to be 13. The reciprocal of a number is 13. Now we need to get our total. So our total here is going to be 0.5 times 10 power negative 3. 0, 0, 0, 5. Okay, so now we get our initial roots x naught. Our x naught, how do you get x naught? You press this value, so you get 1 divided by 13. You get something 0.7 something. So you can set a value near this. So if I'm getting 0.07, then you start with 0.6, maybe 0.06. Then you start with that value as my initial value. So after doing that, now I come to my formula. So if that is the case, then my x1 is going to be now x naught into 2 minus b. Now my b is 13 x naught. This is happening when n is 0. So now, you see if I'm substituting in this value, I'll be having now 0.06 into 2, 13 into 0.06. Then my root here, x1, is going to be, I told you, you press this function on the calculator so that you can easily get the answers. So my first value here is 0.0732. We are giving 4 because our answer is needed 3. And so the tolerance is still very small. If you get this minus this, you're going to get something less than this. So you come to x2, our x2. Now we shall substitute this value 0.0732 into 2 minus 13 into now this value 732. Then you cross. So our x2 here you get, you press down. Here I'm getting 0.0767. Now I want to know, is my tolerance reached that level? I'm getting now x2 and x1. What do you get if you subtract these two things? When you get this, now minus that. This minus this. Do you get something? Okay, let me do it here. 767, 0.0732. Here I'm getting 5300. So here I get 0.0035, which is not less than 0.005. So you go for another value there. Another value, now you come for x3. x3 now, we shall use this as our root there. We shall be having now 0.0767 into now 2 minus 13 into 0.0767 gross. Then our x3 here, the answer we shall get 0.0769. So this is the variable. This was my first, this was my second, then this is my third value. Then I check for the tolerance or the error. So x3 minus x2. What do I get? If I get this minus this. So when you get this minus this, we get 0.0002. And it's less than 0.005. So meaning, therefore, our x value is going to be 0.0769. By now, they want 3 decimal places. So our x3 3 now will be 0.077. So this is going to be now our root. So that's it, members. That's how we handle reciprocals of numbers. I wish you well.